Okay, logarithms. Solve for the x variable. You're basically on a logarithm, you're finding how many 4s it takes to multiply to 256. 1, that's 16. That's 64. Well, let's see. Yup. So there's 4 of them. How many 10s to 1,000? 1. That's 100. And that is 1,000. So the answer is 3. Now, just because there's a 1 over it, it's just the reciprocal of 5. So the exponent's negative. And you can forget about the 1 over it. 25. 125. 625, so that's 4. Negative 4, though. Okay, 3, 1, that's 9. 27. 81. 343, 243, so the answer is 5. Use your calculator. I know it in my head. You use a calculator. Okay, the next page you're solving for x. Now, you notice in both these equations, x is an exponent, so I make the caret, circle, split, caret, circle, split, and down here 2. Now let's do the one where it's just happening on one side first, because these are distinctly different procedures. So 2x minus 4 would equal the log over log. 5 goes in the denominator, and then check outside. There's no multiplier here, so we don't divide. We just put 600 in. So I've got 2x minus 4, and then I go to my calculator. This is how you punch it in. Log 600, close the parentheses, divided by log 5, close the parentheses. 3.97. Then I add the 4, which is 7.97, and then I divide by the 2. So 7.97 divided by 2, just put 3.99 or 3.98. I don't care how you round it. You just got to show the percent. Okay, now this is a distinctly different method. This equation needs to be rewritten so that that number and that number are the same. You use these graphic organizers. 5 is your base on the left side, 625 on the right side. How many 5s would it take to multiply to 625? No, that's 25. That's 125. You see, that's 625. So I rewrite that as 5 to the 4th power because there's 4 5s. So keep that side the same. You can put a 1x plus 1. And this is rewritten as 5 to the power of 4, and then I put a parentheses in the original exponent. Okay? Your 5s go bye-bye. On the left, you got 1x plus 1. On the right, you distribute the 4. 12x minus 8. Now get your x's together. They're like terms. Minus 1x. So it's 9x. So 1 equals 9x minus 8. And then 12 minus 1 is 11. My bad. Okay, 11x minus 8. Then I add 8. That's 9, so 9 equals 11x, then divide by 11. I'm just going to leave it like that, 9 over 11. You can divide it if you want and just round the decimal off. Okay. Next, you have a graph. Here's your x. Well, it's an exponent. I know that to graph exponents, I want to do an input table with 2 through negative 2. And there's also an asymptote I got to figure out, okay? Now your bases of 2, your 2 is a whole number. If that would be a half, I'd start with the negatives, but it's a whole number, so I start with positives. 2, 1, 0, -1, -2. And to find the asymptote, we go -20, -30. Abbreviate if you want, okay? Now, when I do this input, I don't want this -4 here. I don't want to deal with that. So I'm going to do +4, but I'm going to do that after I get all my y's figured out, okay? So -4 times 2 to the power of 2 and add 7, -9. I do not want to deal with that -4. That's part of the exponent. I will fix it once I get all my y's calculated. Now it'd be a power of 1, -1. Now I go to a power of 0. It's 3. Now you got to reset it because you're going to put negatives in. -4 times 2 to the power of -1. 5. Now you go to a power of -2. 6. Okay. I'm guessing these are going to be 7s because that's what we're adding here, but I guess 2 to the power of -20. Yeah, that's pretty much 7. Just go to 30. 7 again. Okay, I'm going to go by ones here. The asymptote's 7. First, I need to remember to add 4 now. So that's 6, 5, 4, 3, 2. I don't care about these. I've got my asymptote. So I go up 1, 2, 3, 4, 5, 6, 7. Everything's going to be below it. So 6, -9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, -1. 1, 2, 3, 4, 5. Down 1. 4, 3. 1, 2, 3, 4. 1, 2, 3. That's all you got to do. You got to have just 3 points because you go down that way because you have a negative in front. That's what's causing it to go down. Then here you just get closer to the line. I mean, you can graph the other ones if you want. It's kind of a waste. Okay, story problems. I deposit $6,000 in an account that earns 3% interest, compounded quarterly. That means 4 times in a year. The percent's divvied up by 4, and it's also done 4 times a year. How much will the account be worth in 5 years? So the 2 important units I have are dollars and years. X is years, Y is dollars. Okay, so the dollars per year, it's not a dollars per year, it's percent, okay? Interest is added. Okay. Now, after you've written that down, divide it by 100 and write plus 0.03 and put a 1 plus, okay? You should always do that. Now, write your exponential growth formula. Blank times blank. It's times, not plus. To the power of x. You don't take a money amount and add a percent to it. That's always a multiplication operation. Equals blank. Okay, this is my percent. Now, the first thing you have to check for, does it say quarterly? Does it? Yes. Then before you add, you got to divide this by 4. And you put a 4 in front of your exponent. So I take 0.03 divided by 4, 0.0075. Then I add. That's what I use for my percent factor. Okay, now these 2 outside blanks are just y values. This is the original y value, which I always know. 6,000. Then my x is the years. Well, I know that's 5. So take 4 times 5. That's 20. And I don't know the new one. You just multiply it. 6,000 times 1.0075 to the power of 20. $6,967.10. Find that, you just multiply the calculator. There's no really trick to it. To find other stuff, you need to be a little more resourceful. Again, percent, divide by 100 plus 0.031 plus. Then set up your equation. If it says quarterly, put the 4 in front of the x, and that 0.03 gets divided by 4 before being added to 1. Okay, next problem. The price of a ticket to an NFL game currently costs $50. It figures to increase in price by 4% each year. How many years before the price of a ticket hits $75? Dollars, years. X is years, Y is dollars. Dollars per year. Again, it's a percent, increase of 4%. So right away, rewrite that as plus 0.04. Okay, and put 1 plus. And then I'll come back up here once I get my equation done. Blank times blank equals blank. And this is to the power of x. It's times again. This is my percent factor. Do you see quarterly anywhere in that problem? No, you don't. So we're not putting a 4 there. We're also not dividing this by 4. We're just going to add the 0.04. And that's 1.04. And that's my percent factor. Okay, now again, these are both money values. Those are Y values, both of them. Your original's 50. Unlike the last problem, I don't have the years, okay? So I leave that as X because that's the answer to the problem, Sherlock. And $75 is that. Now, when I solve for the X power, okay, I need to do the circle split. And I set my power equal to my logarithms. Log divided by log. Well, I know 1.04 is on bottom. You can't put 75 on top on this problem because you got a multiplier outside. So you divide by 50 and then divide 75 by 50. Remember, divide, not subtract. 1.5, okay? That's all she wrote if you punch that in right. Log 1.5, close parentheses, divided by log 1.04, close. Got 10 points. Just put 10, okay? So that's how you solve for the X power, because it's just on one side. Last one. The town's population has been decreasing at a constant rate each year since a plant recently closed. When the plant closed 7 years ago, there was 12,000 people. Now there are 9,500 people. Calculate the percentage change that is occurring each year. So again, you got years and people. X is the independent unit. That's your people's dependent on years. So people per year. You don't know anything about that other than the fact it's a percentage, so I use P percent. Okay, so it's a percent, I just don't know it. So I'm obviously not going to divide it or write it as a decimal when I don't know it. So blank times blank to the power of X equals blank. And this is my percent factor. Well, it's just P. Okay, and these are people. You got to read the problem. You don't put money here. That's not what's going on. People. Okay, now, there were 12,000 people at the beginning. Now, X is years. I have 7 of those, 7 to the 7th power. And now there are 9,500 people, okay? We are not using log over log, okay? You know the power's 7. you're solving for the p. The first thing we need to do is divide out the 12,000. And then I'll know what p to the 7th power equals. Just put 0.79. And then I find the root, but it's not just a square root, it has to be a 7th root. Okay, you got to put a 7 in the index. So you go 7 second, but not x squared. That's for just a square root. I hit the caret key, okay, 0.79. Now don't write that down. You subtract 1 equals, and then times 100 equals, okay, negative 3.3%.